I'm back again with another video about elasticity. So today I hope we're gonna finish the chapter, and tomorrow during class hour I'm gonna post an exercise on the courseware. You're gonna have to do it during class hour, and then on Monday I'm gonna correct it. I'm gonna ask you to post your exercise because it's a homework. It's gonna be graded, okay? So you're gonna have 1 hour and a half to do it. It's like a quiz. So you're gonna start at 2:30. So I'm gonna post it at 2:30 on Tuesday, and at 4 you're gonna have to give me back the exercise. Agreed? Okay. So right now we need to finish the chapter. Let's start. So we studied demand elasticity. If you want to review it, pause the video, go see the demand elasticity and then come back. So price elasticity, the definition is exactly the same as the demand elasticity. So it is price elasticity of supply is the responsiveness of the quantity supplied of a good, of course, to its market price. So if the market price changes, by how much would you change the quantity? That's price quantity supplied. That's the price elasticity of supply. So it is the percentage change in QS due to a percentage change in P, in the price of the good. Okay, so the calculation, it's exactly the same as the calculation for the demand, except that we don't need the absolute value. We don't need it because the result is going to be positive, because the supply slope is positive. So ES is percentage delta QS over percentage delta P, percentage change in quantity supplied over percentage change in price. Mathematically, if you take 2 points, you can start with whichever point you prefer. I started with A, you could start with B. So QA minus QB over, remember the midpoint, QA plus QB over 2, everything over PA minus PB over PA plus PB over 2. So it's the same formula as the one for the demand, except that in the demand, as it's negative, we add the absolute value. Okay, the cases exactly the same as for the demand. So if the elasticity of supply is higher than 1, it's elastic. That means the percentage change in quantity supplied is bigger than the percentage change in price. Now, if elasticity of supply is equal to 1, they're both proportional, the two changes. So it's called unit elastic supply. And at last, elasticity of supply is less than 1. And of course, the minimum would be 0. It's called inelastic supply. That means that the percentage change in price is bigger than the percentage change in quantity. The change in quantity doesn't change that much compared to the price. Okay, now the limits are exactly the same. If the elasticity of supply is equal to 0, that means the quantity doesn't change, and in a diagram, your supply is going to look like this with a 90 degrees angle. It is called perfectly inelastic supply. That means whatever the price, you always supply the same quantity. Okay? Now again, elasticity of supply is equal to infinity. That's perfectly elastic supply. That means you only supply at a certain price, and you're going to have a perfectly horizontal line with a 90 degrees with the y-axis, which is your price. Okay? The only difference between the demand and the supply in this case is unit elasticity. In the demand, unit elasticity is found around the midpoint. Okay? In the supply, it's actually the supply that goes through the 45 degrees line. Okay? So ES is equal to 1 when it divides your graph into 2 equal parts. Clear? It's exactly the same as demand except for this one. Okay? Now I'll move on to applications to major economic issues. The case of agriculture is the first one we're going to see. Now, long run relative decline of farming. Now, the exercise I asked you to try last time is the one where when you produce more, you actually have less income, and this relates to farming. Okay, that's the case of farming. Now I'm gonna have an exaggerated graph. I'm gonna assume that the demand is perfectly inelastic. It is not perfectly inelastic in reality, but it is inelastic. Okay? But to show it clearly, I'm gonna assume it's perfectly inelastic. Now let's plot the supply. This is for farming good. Now, why do I say it's inelastic? Because whatever the price, imagine for example, wheat. Okay? Wheat produces bread. Well, it's the resource to produce bread. If you eat one bread a day, whether the price increases or decreases, you're still gonna eat one bread a day. So the wheat quantity demanded is still the same. Okay, so it doesn't really change, because what we eat, those are necessity goods, and necessity goods by definition are inelastic goods. Okay, so I'm going to assume it's perfectly inelastic. Now let's look at the supply of wheat. I'm going to plot the supply here, and I'm going to have an equilibrium over here with an equilibrium quantity, QE, and an equilibrium price, PE. Okay? Now I'm going to look at the revenues of farmers. How do you calculate the revenue? The revenue is simply the quantity that you sell times the price of the goods sold, which is the price at equilibrium, which is the market price. Now let's calculate this revenue. Forget this, okay, for now? Okay, revenue at E, at this equilibrium that we have right now, is going to be equal to the quantity at E times the price at E. Okay, so that's the revenue we have right now. But with technology, what do? You produce a lot more compared to a long time ago. Now, instead of having people work in the land, you have machines work in the land. They produce a lot more. So what's going to happen to your supply? Your supply will increase. Increase means it's a shift to the right. Okay, shift to the right. I'm going to increase my supply. Do you see it here? This point becomes over here. This point becomes here. This point becomes here. That's an increase. Even though it looks lower, it is an increase in supply. Do you see it? Now let's see our new equilibrium. I'm sorry for this. It's okay. You can still follow. Okay. Here is my new equilibrium. Do you see it? E prime. Let's look at the new price. PE prime is here. QE prime is equal to QE. In reality, it's almost equal, okay? But I exaggerated to show it to you. Okay, let's calculate this revenue here. Revenue at E prime is equal to QE prime times PE prime, okay? QE prime is equal to QE, it's constant or almost equal. So our E prime is equal to QE times PE because of the equality between these two. Okay, but what about PE prime, PE prime here. Okay, what about PE and PE prime? Are they equal? Absolutely not. PE prime decreased a lot due to the supply shift. So what's going to happen to the revenue? So this PE decreased to reach PE prime, while the quantity is the same. So what's going to happen to the revenue? It's going to decrease. Okay? So that's what's happening to farmers. When they produce a lot more, they actually lose income. They lose money because from their revenues, they're going to have their money. So can we actually let them lose money? What's going to happen? These are necessity goods. Okay. If they don't produce, they stop producing this. They go to something, they see that they're not making money while they're working harder. So what are they going to do? Okay, let's do something that is more beneficial to us. Let's go invest somewhere else, sell the farm and do something else. What if all the suppliers do this? Are we going to be able to survive? Well, we need food. So we cannot let them just quit. We have to do something to make them have the money they need in order to survive so that we can eat. Okay, so this is where the government is going to come into play. Okay? So now that we did this, please take a screenshot. Please, guys, go ahead, do it. This is the case for farmers. I'm going to rewrite it here because I need this side. So RE is equal to QE times PE. RE prime is equal to QE prime, QE, okay, times PE prime. I'm going to put the equality, even though it's not totally true. It's almost equal, not equal, okay? So, and PE prime is a lot less than PE, which means RE prime is less than RE. Now I can delete this to move to the role of the government, okay? So, what is the government going to do? It's going to call for crop restrictions. Okay, so that's little 2. It's a solution. I can show it on the graph because the graph is exaggerated. Okay, so the government is going to say, okay, you're not going to supply that much to make your supply shift. No shifts. We're going to make sure that the quantity supplied stays constant or limited. So you can supply this. When you come here, you stop. Okay? So I'm going to explain it this way, even though it's not exact, but it makes sense for you. Okay? We're going to try to push it back. Okay? If you look at the book, they have the real graph. It's actually going to become inelastic supply with a quota. That means it comes over here. It does something like this. Okay? It doesn't come over here. Now, so what's going to happen? We're telling the suppliers, okay, you supplied so much wheat that it pushed the price. I'm sorry, I need to be here. That's how you see me. So we supplied a lot of wheat. So if we put that wheat on the market, the prices are going to decrease. You're not going to have enough income. So what we're going to do, we're going to put a quota on the wheat. So you can supply a certain amount of wheat, but keep the prices at PE. Okay? The rest of it, we're not allowing it in the market. Because if we allow it in the market, the prices are going to go down. You're not allowed to put it for sale in the market. You have a certain amount you put for sale as long as we keep PE. That's your quota. The rest, you dispose of it. Okay? So it's not in the market. Clear? Otherwise, the incomes decrease and the farmers are desperate. And they might quit. Clear? That's crop restriction. So it's simply a limit on the quantity that's going to go to the market. Okay? You limit the quantity to keep PE and not have a decrease in price, in equilibrium price. I hope it's clear. Okay? I think you got the idea. we need the prices to stay here in order for the revenues to be back at the revenue where suppliers are making some money. I'm gonna move on now to another part. Take a screenshot if you need. For this, go back to the book. It's you have it in the graph. Okay? Can I? Yes, I think I can. So let's do the other case. So the first case was the case of agriculture. Now I'm going to give you the tax. It's also another application of this. Okay, I'm going to push these down. I need them, that's why I keep them here. My magnets. So that would be big 2. And so we did this one. Impact of a tax on price and quantity. That's big 2. Using elasticities, of course. Impact of tax on not N, on price and Q. Okay, to do this, I made a graph for you. Okay, so I'm going to pick it up. Here it is. This little graph. Yeah, I made it beforehand to not waste time. Is it holding? Oh, not that much. I didn't try this before. Oops. Yeah, it's kind of holding. Let's put it here. Here. Let's see. Okay, I'm gonna put a lot of them. And yeah, you only see the back of my head. Okay, guys, shall I start? This is the case of gasoline. It's the graph you have. Let me just check here. I wrote it. Chapter 4, figure 410, gasoline of $2. The case of gasoline with the $2 tax, page 76. Okay, the graph in the book is very small, so you might not notice what they are trying to tell you. While in this one, I made it big enough so that it's obvious. Okay, so let's try. Right now, it's the case of gasoline with the exact numbers they gave you in the book. So I have a supply of gasoline and a demand of gasoline. Yeah? Now, if you notice, the supply is sleeping, more horizontal than the demand. That means the supply, if I compare the elasticity of the supply with the elasticity of the demand, I'm going to have the demand is more inelastic than the supply. The demand is more vertical, that means more inelastic, while the demand is more horizontal, that means more elastic. Okay, now let's imagine, right now my equilibrium, is at $2 and my equilibrium quantity is at 100 units. I don't care about what unit they're using. Okay. Now the government comes and tells you, okay, now we're gonna have a $2 tax. Who pays the tax? Normally people think it's the demand. Okay, the supplier is gonna add 2 dirhams to the price. Whatever price it is, the supplier is adding $2. That's exactly what the supplier is gonna do. Now, if you want to know how it works, okay, how does it work? The demander comes and pays the market price, okay? The one who pays the tax literally pays it, that gives it to the government, it's the supplier. The supplier gathers it from wherever it is and gives it to the government. Now we're going to see, even though the supplier gets it to the government, is the supplier the one paying for it really? Or is he going to shift the whole tax to the consumer, take it from the consumer, and then give it to the government? That's what we're going to study right now. So here in this case, the government said $2 tax. So what the supplier is going to do, it's going to add $2 vertically to its supply, isn't it? So if the price was here, I'm gonna add $2 and have a new supply. That's what actually I have behind here. So let's see if it works, if I did my job correctly. I did plot the new supply. Here it is. So here is my new supply where I added $2. If you see vertically here, it's $2. $2, $2, $2. I did it. And of course, so the distance between these two lines, these are two supplies. This is $2. Everywhere it's $2 that I added. Okay, now let's look at the equilibrium price. Normally, without calculating, without really looking clearly at the graph, we're going to say, okay, the new price of the market, it was $2, now it's $4. No, that's where you're mistaken. It's not going to be automatically $4. Let's see. Here is vertically $2. We agreed that I added $2 everywhere. Okay, the same amount vertically. So let's look at the difference between the first supply and the second supply. Oops, sorry guys, I did bring my, yeah. I almost broke it. Okay, where's the blue pen? Yeah, I do have a blue pen. This one can work for paper. So let's do it vertically. Can you see? So vertically, I already did it with a smaller pen. Now each square here is 10 cents for the price. So here I have $2 from here to here. You see, it's $2 everywhere. Okay. Now let's look here. Is it totally $2 from this? This is PE and this is PE prime. Look at where PE prime is. Is it $4? Nope. It's actually, are you seeing? PE prime, if you look at it, it didn't reach $4. Here it's 3.8. You see two little squares that are missing to reach $4? Huh. Remember, what does the consumer pay? Pays PE. It always pays the market price. PE, that was $2, and now it pays PE prime, the new price at equilibrium, which is $3.8. Huh. So it pays this amount. This is the distance paid by the customer. It's the difference between PE prime and PE. So the customer, okay, pays PE prime, part of the tax, okay? Tax. Customer pays PE prime minus PE. So the customer pays 3.8 minus what it used to pay, which was 2 of the tax, which is $1.8. All this is in dollars. Okay? It used to pay $2. Now with the new tax, it pays 3.8, which means from the $2 of the tax, it only pays 1.8. Okay, so if the consumer pays 1.8, who's gonna pay the rest? The government takes the tax. I don't care from where you get it, Mr. Supplier, either from your consumers or from your own money. Okay, so here you're gonna have 20 cents paid, so 0.2 paid by the supplier. Okay, so the rest of the tax is gonna be paid by the supplier. So the supplier, so that's the customer, the supplier will pay the tax, minus PE prime minus PE, which is going to be, in this case, $2 minus $1.8 that is paid by the customer, which is equal to $0.2. $0.2 meaning 20 cents paid by the supplier. Okay? So these are your rules. When it comes to tax, the other pens for the board. Okay, when it comes to tax, we're gonna divide it into customer, the demand side and then the supply side. Tax, the share paid by the demand, share paid by demand is gonna be PE prime minus PE, okay? Then the share paid by supply is gonna be the tax minus whatever the demand paid, okay? Don't forget the parentheses, okay? If you wanna do it directly with avoiding the mistakes due to the minus sign, it's minus PE prime plus PE. Okay? I hope you got it. Isn't it correct? So let me try this one. $2 minus 3.8 plus 2, it's exactly that. Is this clear? I hope it is. I'd like you to review it really clearly. Take a screenshot, because in the book, the graph is not as good, okay? Yeah, for once I'm criticizing the book because my graph is bigger and better. Okay, so we already have 27 minutes. I'm gonna stop here. I'd like you to, so on Tuesday, which is for you tomorrow, I'm making these during the weekend. So on Tuesday, what you need to do, I'm gonna post an exercise in the courseware, a long one. You're gonna start it at 2:30, finish it at 4. No, it's on Tuesday, so you start it at 4:30. I'm sorry, because you don't have class at 2:30. You start it at 4:30. You send it at 6. If you don't send it at 6, you will have a bad grade. Okay, guys? And this is no April Fool's joke, okay? Do your exercise. I also need you to send me 2 little paragraphs written to explain to me what a minimum floor is and what a maximum ceiling is, okay? Take examples of Morocco right now, okay? We do have some maximum ceilings here. So guys, goodbye. I'm gonna give you an exercise and we're gonna correct it next week. Bye-bye. Love you guys. Bye.